Indeed, the narrative around the CO2 is changing. It's not just a byproduct of industry to be mitigated, but it has to regain its original role in the life cycle for energy production and material transformation. Hi Gabriele, nice to see you here at the GET.
Yeah, my pleasure here. My pleasure being here, and I'm glad you're here too. And I'm happy that we can have a chance of exchanging some ideas. I've just been coming out of the conference where our CEO was telling about how CO2 and hydrogen can actually combine and make e-fuel. So I think it's an interesting topic we can talk about.
Oh yes, Gabriele. Indeed, the narrative around the CO2 is changing. It's not just a byproduct of industry to be mitigated, but it has to regain its original role in the life cycle for energy production and material transformation. Let's start from the origin. CO2 is a key element of the atmosphere, and it plays an essential role in the photosynthesis process, which is vital for plant life. CO2, through photosynthesis, CO2 is captured from atmosphere. It's converted into glucose, which is used by plants for energy and growth. And plants then release oxygen as a byproduct, which is essential for animal life. So CO2 is part of the cycle for life, for energy and material transformation. And we as Nextchem want to consider CO2 in this original role as part of a cycle, in a sort of circular approach to close the loop for energy production and material transformation.
Well, indeed, Paola, I fully agree with you, because CO2 often is perceived as a bad molecule, but it's not that case. I mean, CO2 is essential for life, and we, as a living creature, we would not be here talking if CO2 was not there in the atmosphere. The point is that we as a human race are changing too much fast the concentration of greenhouse gases, and so we are not allowing enough time for the environment to adjust to these changes. So we in Nextchem have been working on these kind of technologies that can implement and capture CO2, and we can benefit from this kind of usage of CO2 and changing it from an environmental issue into actual a resource where CO2 can be combined with hydrogen, as our CEO was saying, and it can be then transformed into a resource. So instead of having a linear economy where CO2 is, hydrocarbons are used and CO2 is generated, we can enter into a circle economy where CO2 becomes a vehicle for putting energy on it and producing synthetic fuels that then can be reused and reused into a virtual circle economy.
Indeed, Gabriele. The issue is that CO2 is a lazy molecule, so we need to spend additional energy to reinsert it in the cycle. One possibility, as you were saying, is to react CO2 with hydrogen, because hydrogen is a molecule that brings a lot of energy with it. And by reacting biogenic CO2 and hydrogen, we may have green methanol. And methanol can be used as a fuel or can be used as a feedstock for other chemical processes. So in this way, we can change drastically the approach to fuel production.
Yeah, and it's not just methanol, I think, Paola, because we can work with methanol and obtain other fuels, but we can also work with CO2 directly and hydrogen, and we can tackle and create, and this is what Nextchem is doing actually, create new fuels all the way from gasoline or even better to SAF. We have technologies that are working on that, and we are deploying this kind of activities. We have, with our competences during the years, we have developed technologies that can reduce the amount of energy, because as you said, the key role is here, the key word here is energy. Because being the CO2 a lazy molecule, we have to push it out of its comfort zone, and that requires energy. So what we are tackling is how to reduce the amount of energy that is needed for all these parts. So in our next decarb, we have focused the attention on how to make it more efficient with the least carbon footprint of possible. We have then increased also our competences, not only in the carbon capture, but also in the utilization of the CO2 with hydrogen to produce fuels, and in the handling of the CO2, which is a molecule that needs to be transported many times, stored. So you need to have large-scale liquefaction. So that is another key point that we've been tackling.
Yes, Gabriele, you know, recently our portfolio of technologies has grown to include NX Adwin methanol suite, groundbreaking solution for methanol, low carbon and green methanol production, which offers lower capex, lower opex, high efficiency, high availability. It's a cutting-edge approach to methanol production.
Interesting. Yes, I remember that. And besides methanol, we can then elaborate on that, and we can produce other fuels. The point is that we have to have a push there, and we need a regulatory framework to be aligned with this, because the e-fuels that we are intending to produce need to still have a gap with respect to the fossil fuels. And up to now, we still have maybe 4 to 5 times the cost to do synthetic fuels than not what is the fossil fuels. But it is a must, because we cannot go on in using the hydrocarbons without actually taking care of the consequences of burning hydrocarbons. We have been increasing the amount of CO2 in the atmosphere, and there's a clear link between the climate change and the amount of CO2 that we've been putting in the atmosphere. For 100 years, we've been spoiled in using hydrocarbons without taking care of consequences. But the byproduct of the combustion is none less than like when you're using water and you're putting water into a chemical plant. You never throw water back into the river without cleaning it. So why are we burning hydrocarbons and we are not cleaning the air before that? So that is part that the regulatory frame has to tackle, the fact that we've been spoiled in using hydrocarbons for 100 years without taking any consequences. And where does this come from? This comes from the fact that the resource is there, and I believe it's important that we can still benefit from hydrocarbon resources. We need just to learn how to deal with the byproduct. And a byproduct means carbon capture. Carbon capture and sequestration or utilization. That's the key, I think.
Oh yes, Gabriele, but I think there is also another possibility, which is to react CO2 with ammonia and produce urea. With our NX STAMI urea technology, we can produce urea, and urea is a vehicle to bring nitrogen to the plants. Urea is a fertilizer. Again, CO2 is part of a life cycle, and is one block that can bring to material transformation. Again, CO2 is part of a life cycle.
I agree, I fully agree, because we are looking at CO2 in Nextchem as a key component, not anymore an environmental issue, but a key component that you can recycle, and you can carry energy, or you can carry nitrogen. And so if you have fuels and SAF, methanol, you're using the carbon and the CO2 to carry the energy, renewable energy. If you have urea, you're using the carbon and the CO2 to carry nitrogen. So carbon, CO2 is not a bad molecule. It's an important, interesting vehicle for a circular economy.
Oh yes, and I agree with you with what you were saying before. The cost is still an issue in this case, and probably production of green methanol has a cost which is still higher than traditional methanol. Nevertheless, in this transition path, we are considering also to capture CO2 in traditional methanol production. And in fact, one of the main units in our NX Adwin suite for methanol production is CO2 capture, with the purpose to reduce CO2 emissions for sure, but also to convert CO2 in other products. This is a physical absorption of CO2, which can lead to very high capture rate. And this is also one of the processes we are studying, and we are trying to optimize to reduce energy consumption and make the process more efficient.
Absolutely, that's the key word. Efficiency, reduce energy consumption. Great.
Yes, Gabriele, and now the potential for sustainable development is immense. And by turning CO2 into a resource, we are not only addressing the climate change, we are also fostering innovation, we are creating jobs, we are paving the way for a circular economy.
Yes, Paola. It's a complex journey, very complicated in front of us, but it's essential for our future. And we need to have collaboration between industries, government, and institutions. So that's the key. We have to go there.
And that's exactly what we as Nextchem are doing. We are collaborating with several universities in Italy, like Politecnico di Milano, but also in Germany, in England, and with several research institutes. Our main characteristics is the ability to make things happen in the real industry, thanks to our experience in process engineering, in technology, and thanks to the countless number of plants that MAIRE has realized in the world.
Thank you, Paola. It was a great pleasure talking with you today at the GET.
Thank you, Gabriele.